This is 7-83, Integrated 1. It says, Mitchell likes to study the weather. He's fascinated by the sophistication of the computer models used to make weather predictions. Mitchell wonders if he can make his own model to predict the next day's high temperature in his area based only on today's high temperature. He selects 11 days at random and gets temperatures from the internet. The results from his computer spreadsheet are shown. So I'm thinking right here is all the days. This is random and next. He selects 11 days at random and gets the temperature from the internet. Does anyone understand what the next means? Random and next? No? Is that why you're asking me this question?
Yeah.
Oh, I'm thinking it's... So, he's fascinated. I try to understand what this problem is about. Wondering if he can make his own model. Okay, so I think what's happening in this problem is when you know how hot it was today, can you predict tomorrow? So I think he's just using, that's why it says random and then next. So instead of doing, today and then tomorrow, then the next day, then the next day, then the next day, he's just picking random days. Like one day it was 93.2, but the next day it went up. This day it was 69.8, the next day it went up. Does it always go up the next day? I'm just wondering. No, not always, because
sometimes it goes down.
Yeah, sometimes it goes down. So can you guys understand what he's trying to do? He's trying to figure out tomorrow's weather by judging from today's weather, I think. So I don't know if that's a good idea. Well, really, weather doesn't change drastically between one day and the next, so maybe he's got something there. So here's an LSRL, and I hope you guys remember what that is. It's just a scatter plot of all these, and there's the line that goes through the middle of it according to his calculator. And then this thing, remember this thing, it's a residual plot. And remember, residual plots show us if a linear model is a good model or not. So if it looks curvy, then we say a linear model wasn't a good model. Sometimes they're a little hard to judge. So write a few sentences that describe the association. Remember to include interpretations of slope and r-squared. So this is 7-83, letter A. Write a few sentences. Okay, so how do we describe association? Does anyone remember the kinds of things we say? Sandy?
Come on.
We usually, don't we say things like strong, positive, or moderate?
It's a strong, positive, linear-ish.
Yeah. Seems like. I mean, because we would say it's strong because they kind of look like they're lined up pretty good.
That's why.
Yeah, and they do seem to be going in an upward direction. So that would be positive. If they look like they were going downhill, it'd be negative. Strong, positive, linear, because we think that they kind of look like they're lining up linear. So that's good enough for the that. And then we have to include interpretations of the slope. So that would be the positive part, right? And r-squared, does anyone remember what r-squared is? I thought that R had something to do with the I thought it was like the spread of the data. Like, remember, it shows how tight the data is. See, like, that's R. If R was 1, that would mean all these little dots would land exactly on the line of best fit. But if something was scattered out super wide, R would be like 0.03 or something. It wouldn't be close to 1. So that's what R is. is like how closely they are. Basically, it tells you if it's a strong or weak correlation. So we could say, well, we already said it was a strong correlation. So I think that's enough right there.
Yeah.
Yeah, because we said strong, which that tells us about R, and we said positive, which tells us about the slope, and we said linear. So let's do letter B. Letter B says, use the graph to estimate the largest residual. To what point does it belong? So on these ones, they want you to find, this is the residual plot down here. And if you remember what the residual plot does, is it kind of measures how far each of these points is away from the line of best fit. So this is kind of the line of best fit. And then I see that this one way up here looks like it's the farthest away. And so I would follow it down and see what it goes with. Like it goes with, how's this going though? They count by 10, 20. I don't know, that looks like 60 to me. Wait a second. 65, is it 70? Yeah, because I can see it on this plot. And I see that it's, because that has got to be that. So you think it's 70? Okay, so they say the largest residual belongs, it's actually the day after the 69.8, which is about 70. So actually you can find it right here. It was, the one closest to 70 was that one, right there. You can find it. Oh, is there one that's 70?
No, I was going to say 69.
Oh, yeah. Yeah, you can go 69.8. It's about 70. Like, when you look on the graph, you can't tell exactly, like, the scale isn't going to enable you to be able to tell. And if you look at this way, it looks like it's about somewhere between 15 and 20. So your book says that it's about 17. So I didn't write what all these mean. I'm going to say largest residual is about 17. And then I'm going to say, what was the other question? What point to this point? That doesn't look very nice. So the largest, it would sound better if you wrote it, the largest residual is about 17 and it belongs to the point 69.8. I didn't write it very well. That's letter B. Letter C says, using the LSRL, estimate tomorrow's high temperature based on today's high temperature of 55. Use appropriate precision. So we're just going to use the LSRL that they gave us right here. So we're going to go 13.17 plus 0.85, and then we got to plug in the number they gave us, which was 55, and then we need to get out my calculator to do that. Okay, so 0.85 times 55, and we got to do it quick because I only got like 1 minute left before it's too long. 0.85 equals that number plus 13.17. So it's about 59.92. That's the degrees. That's the weather we think. That's letter C. They said it was about 60. That's what it says in the book because they rounded it. And then can we do the last one super fast? Consider the upper and lower bounds of the prediction. Is Mitchell's model ready to replace the complex models of the professional meteorologists? What do you guys think? No? I'm going to turn this off and then we can talk about it.